Okay, so as a reminder, I'm Dr. Clare Martin. I work for a company called Astroscale here in the US. And I actually thought I would start my talk today with my journey to this point. Now, there are, I confess, two misleading aspects about this slide. The first, I didn't really dabble in dance before I became a space nerd, but our team likes to have a little bit of fun. And the second, really, is that my journey has not in any way been a straight line. When I left academia after my PhD, I knew I really wanted to stay in space. So I joined the civil service. Some of you might be able to tell that was actually in the UK. The accent gives it away. And there I spent many years studying the space debris environment. Hours and hours in a computer lab, looking at the long-term evolution of the environment, what our activities would mean for that, and what perhaps we could do to mitigate that effort. And then after the civil service, I left and I actually started building spacecraft. Small spacecraft, some larger. And now that I get to join Astroscale, I have the pleasure of building spacecraft to actually help the sustainability problem. So in ways, more of a circle than a straight line. So when we say space debris, what do we actually mean? So in its simplest explanation, really, it's any object that is not performing a useful function in orbit. So that could be the rocket body, from a launch that's put the satellites in orbit. It could be the fragments from explosions or collisions. It could just be a defunct satellite, something that has finished and served its useful life. And yet, the increasing number of objects that aren't performing a useful act in orbit is providing an ever-increasing risk to those objects that are. And we all know in this room how dependent we are today on satellite technology. Whether it's using the Maps app on your cell phone to find that restaurant to meet your family for dinner that you've never been to, or supporting the monitoring of disasters around the world. And yet, unfortunately, we are only making life harder for ourselves. When I first started working and studying the space debris field, my then boss gave me this analogy. So we spent a lot of time talking to the public, to other companies, to insurers, trying to raise awareness on the space debris issue. And the analogy he gave me was this. So this is actually a pound coin. I went old school and I still had one at home. That if something just this size in low Earth orbit hits your spacecraft, it'll do the equivalent damage as if you put your spacecraft in the middle of a highway and hit it with a minivan doing 60. Just to try to picture the damage that can be done by space debris. But the good news is that the awareness is growing. The awareness is growing amongst the public, amongst companies, amongst the government, and therefore so is the demand to try to find a solution to the problem. So at Astroscale, we have a vision for space sustainability. But to achieve this, we actually have to change our approach, change the way we are thinking. And I like to use an analogy to explain what I mean here, with the humble water bottle. So this, courtesy of the hotel, is something that was designed. It was manufactured. It was very conveniently filled with water and shipped so that I could stay hydrated during this conference. But when I finish it, I actually have options. I could put some more water in it and continue to use it as it was intended. My childhood self would undoubtedly have been making models and experiments with this. And then ultimately, when I'm done, I can take it to one of the receptacles around the convention center, and it can be recycled. In space, what do? We design an object, we manufacture it, we launch it and use it for the mission for which it was designed, and then we just leave it. Sometimes we'll leave it in an orbit where we think it will be less impactful on the future. Sometimes we'll leave it in an orbit where it can decay over time. But ultimately, when we are finished with it, we just leave it behind. But But there is a way to change this situation. We need to change the way that we're thinking and look at making this economy more circular. But to do that, there are 3 hard challenges. The first of those is the technology. We have to have the technologies that make on-orbit servicing a viable solution. And then we have the policy. The policy, whether that's through norms of behavior or regulation, to actually help support and encourage a sustainable space environment. And then we have the economics, the how to actually create a circular economy in orbit. It's a very good job. I love hard problems. So if we look at the key technologies, okay, that could enable on-orbit servicing, and these are the key technologies that we focus on in Astroscale. The first of those is the rendezvous and proximity operations. I like to just call that the hard math. So it is the algorithms and the sensors that enable an RPO to occur. And then the second is actually the mechanical aspects and the mechanisms, the docking, the interfaces, and the robotics that would allow you to perform the service on orbit. The third, and I think actually the most important, is the mission, safety, and operations. To be able to perform on-orbit servicing in orbit, you have to take into account all of the factors of safety and your operational procedures, because the last thing you want to do is to cause more space debris in orbit. And as we move forward, autonomy, as my previous speakers have spoken about, is going to become more and more important to enable us to be more responsive and to do more with on-orbit servicing. The amazing team that we have at Astroscale actually move forward every single day the technology and the policy and the economics that will help us solve this problem. So the first of those missions you saw actually launched 2 years ago, and the next one does go this summer. It is a very exciting time. So where are we today? Well, the actions from governments around the world, that is growing. It's growing in the US, the UK, Europe, and Japan. For example, the recent FCC change in rule that took the lifetime for disposal in LEO from 25 years down to 5. And the active debris removal missions that are being worked on now around the globe. And commercially, there are companies as Astroscale that have sustainability at the heart of everything we do, but this is an ecosystem, and we have to work together. And that ecosystem includes space situational awareness, it includes the launch vehicles needed to get us there, the future commercial space stations and fuel depots, just to name a few. But by working together, we will be able to achieve economic and environmental stability in space. And we will do that by solving the hard challenges in technology, in policy, and in economics. And we will do that through on-orbit servicing. And now I'll pick up my water bottle so no one trips over it. Thank you very much.
Thanks, Clare.